Hi, this is Ms. Delosier, and these are some quick notes on historical biogeography, which sounds really big and hard and like it's social studies, but really it's not. Historical biogeography is the branch of biogeography. There's two branches, historical and ecological. We're going to talk about historical. Historical biogeography is the branch of biology where we're studying where organisms live and how they got there. So we're basically studying organisms' dispersal and evolution in different geographical areas of the world, and that's really it. And so we've already talked about this a little bit in terms of adaptive radiation, but what we're going to look at specifically is just a big generalized example of biogeography. So if I start with some mainland and some islands, because it's easier to talk about on islands. And I have species A living on the mainland. Now, I'm going to make species A a turtle that can swim to the islands, because we've already talked about birds and that's boring. So the turtle species is going to move to that island. And there's one of three things that can happen. It can get to that island and completely die off because the ecosystem is completely not favorable for it, in which case species A isn't there anymore. Or it can remain species A there, or what we can have happen is what we're going to actually have. We're going to have it actually change over time. It's going to slowly adapt, and over many generations it's going to become a new species. So this is going to be speciation due to separation, which is going to be allopatric speciation. You don't need to know that word now, you will need to know it later. But species B is now found on this island. So species A has now split. I still have species A on the mainland, and on the island I have species B. So that's that. Now you'll see that obviously my turtle species can keep traveling. So if my turtle species spreads to those two other islands, island hops along, I'm going to go ahead and have a mountain range actually on that second island. So species B gets to the first side of the island, and on that left-hand side of the island, we'll just say it's really similar ecological conditions to on the first island. And so species B is going to stay species B. There's going to be some gene flow. They'll swim back and forth, all the same species. However, the turtles that make it onto the other side of that mountain range, we're going to go ahead and we're going to have some different ecological conditions. We'll say that there's different moisture levels and different vegetation present there. And so we're going to end up with some changes accumulating over time there, and we're going to end up with species C. So species B is going to become species C. We're going to have some speciation occurring there also. And again, that would be allopatric because they're separate. On this other island down below, we're actually just going to have the same thing that happened on the first island. That's going to go ahead over time, different changes in the ecosystem, food, predators, whatever. We're going to get species D over there. So you see, I started with one species, and as it spreads out to the different ecosystems and over time as the species is reproducing, it's going to accumulate small adaptations to the ecosystem, so the organisms best suited for each individual island are going to survive. And I've ended up with species A, B, C, and D now. And then I'm going to do one more. Species C is going to go ahead and move to that last island, and it's going to go ahead and become species E. So basically, that's a really convoluted, complicated way of saying that the species can move from island to island, and if there's no gene flow between them, or if there's drastically different ecological conditions, you can get speciation into a new species. And one of the ways that we look at this with historical biogeography is not only just looking at that pattern, not just that pattern of where they actually are living, but we're also going to look at the branching pattern. So like which ones came from which. So we would do that using kind of a evolutionary tree. It's a really kind of basic tree. So I'm going to have A going off, and A initially divides into B, right? And then from that, B has got to split into species C and species D. And D is not more closely related to C. So I need to have B in the middle, right? Because be split twice. So we're going to do a little erasing. We'll put species D over there on the side, and then B in the middle, and then C there. And then, of course, C splits into E. So let me go ahead and do that split, C to E. So that's kind of a little tree that we would use to go ahead and show those relationships between dispersal and how those organisms came to make it to those specific environments. And that's really all that we're talking about with biogeography, and how we talk about how biogeography provides evidence for evolution. What you can look at is specifically in things like Darwin's finches and the Galapagos tortoises. You can actually look at tracing those morphological differences and those phenotypic traits from the mainland to the islands, and you can kind of see how those traits radiate out, and you can kind of trace these patterns. Again, my example's super generic. If you actually would like to see a very specific example, you can come on into class and we can actually trace through the dispersal patterns of either the Galapagos tortoises or the finches. I hope that helps. It's really the easiest of the ones because we've talked about adaptive radiation already, and if you need any help, just come see me.